All right, part B is factoring polynomials by grouping. So steps to factor. 1, we group the first two and last two terms. We factor out the GCF of each group. Then we're going to factor out the common binomial. If necessary, use other factoring techniques to complete. So if you look here at this example, I have AX plus AY plus BX plus BY. I group the terms, the first and last two terms. I factor out their GCFs, and then I factor out the common binomial. And what I'm left with is my factor. So looking at with numbers, we have group the first two. Notice when I'm grouping, I include the negative in there. GCF, factor out. If it's a negative leading, then your GCF is going to be negative. And then factor out the common binomial. And I'm left with this. Sounds easy enough, right? All right, here we go. So we have x cubed plus 3x squared minus 16x minus 48. So we're going to group the first two and the last two. Okay, so that's step 1. Step 2 is to find the GCF of each grouping. So the GCF here is x squared. The GCF here is negative 16. So I factor that out. I'm left with x squared times x plus 3 minus 16 times x plus 3. Okay. Step 3 is to factor out the common binomial. So I'm going to factor out the common binomial, which means I'm dividing both terms by x plus 3. Okay, when I factor out x plus 3, what am I left with? I'm left with x squared minus 16. So I have x squared minus 16. And if it's necessary, then I'm going to use other. I'm going to use other forms of factoring. So I have x squared minus 16. This is a dot situation, difference of two squares. So I can take the square root of x squared. It's a mental thing, right? It's x minus 4, difference of two squares. If I have a minus binomial, I'm going to also have a plus binomial. Now it's fully factored. I can bring down my last factor, which is x plus 3. And here's my fully factored 4. Okay. Now, if it was an equal sign, then I could proceed and set them equal to 0 and solve. But it's just asking to be factored, and that's all I'm going to do. Okay. Example 2. So example 2, following the steps. Step 1, group the first terms. Step 2, find their GCF. GCF here is x to the third. GCF here is 8. And I factor out the GCFs, and I'm left with x cubed times x minus 2 plus 8 times x minus 2. Step 3 is to factor out my common binomial, which in this case is x minus 2. When I factor out x minus 2, I'm left with x to the third plus 8. Okay, now you may be tempted to stop right here. We're going to talk about this further tomorrow, but this is sum of cubes. And sum of cubes has their own rule. For sum of cubes, if I have a cubed plus b cubed, it factors out to become a plus b times a squared minus a times b plus b squared. And again, tomorrow we're going to dive a little deeper. But to find your a's, so in the case of this one, our a equals the cube root of x cubed, and our b equals the cube root of 8. So a equals x and b equals 2. And so I can plug those in and find my factors. All right, so we have x minus 2. So this is where it says that step 4, using additional. So x minus 2 is good to go. And here we have x cubed plus 8. It's going to be factored using sum of cubes. So where a and b are, I'm plugging in x and 2. So here where it says a plus b, it's going to be x plus 2 times where it says a squared, it's going to be x squared minus where it says a times b is x times 2, which is 2x. And where it says b squared is going to be 2 squared, which is 4. And so I'm left with x minus 2 times x plus 2 times x squared minus 2x plus 4. And this should kind of look familiar from part A when we have to factor this using the quadratic formula. So hopefully you see that. But this isn't fully factored. It's not asking to be solved, just factor. All right, our last example. We have x to the 4th plus 3x cubed plus x squared plus 3x. Okay, so step 1, group the terms. So they're grouped. Step 2, factor out your GCF, x cubed, x, and that leaves me with x cubed times x plus 3 plus x times x plus 3. Step 3, factor out your common binomial, which is x plus 3. Factoring that out leaves me with x cubed plus x. Okay. Step 4 is going to come into play here because I still have a GCF. So x plus 3 is good to go. But here, I'm going to have to factor out a GCF. The GCF is x. So I factor out x, and that leaves me with x squared plus 1. So my factor form is x times x plus 3 times x squared plus 1. And that's it fully factored. Again, I'm not solving because there's no equal sign. I'm just factoring. All right, that concludes part B. Tomorrow we'll be doing part C and D.